So we should start at the very beginning and look at the steps in program development. This is one of the most overlooked and really at its core the most important steps. What we do here to actually create a workflow around looking at holistically how it is we're going to put a program together really does pay dividends in the end. Now, a lot of the programs we'll be doing just as part of the end of chapter exercises and things like that won't necessarily be large enough where you will see a tremendous amount of benefit to really using a rigorously standardized steps in program development. But what I can tell you is that no good, successful, long-term, large project in development benefits from not having a standardized and rigorous adherence to the steps in program development. These really are the 7 tenets that every large-scale application really relies on in order to be the most successful. So right here on page number 2, we're going to start at the very top, is to define the problem. Here we have to be exceptionally careful. The text makes it seem as though this is really just the developer problem. But really when we go through and we define the problem, it's important to remember that we need input, output, and processing, not just based on what your needs are as the developer, but really we have to talk to all of the stakeholders who are involved. Talk with the end users and see what it is that they need out of the system. Talk with management and see what it is that they need out of the system. If there's any intermediaries in between here and there that are going to have either an input into the system or who are going to get an output in the way of data or reports or inventories or tracking or whatever it happens to be, make sure to involve everybody so that you get a more full and complete version of what is happening, the goals of the project. The more complete that version is, the more likely it is you'll actually develop it into a solution that's going to work for everybody. Next, what you want to do is outline the solution. This, again, is not just based on what you think the possible or probable steps in the solution are, but this really is working with those stakeholders, again, to put together a solution that makes the most sense based on the input that everybody has. You will put together to figure out the major steps in processing that are going to be involved, any subtasks, if there are any. If there's a user interface, or in modern design, if there's a data interface where it is that you are taking data in from another external source, any place where those are going to interact with what your data or your user interactions are going to be, you have to be able to consider those before you start developing a specific solution. Any repetition or control variables you're going to need, and any of the mainline logic as you're going to put those together. If none of that makes perfectly clear sense, that's okay. It is literally what we spend the rest of the course talking about. From there, you actually develop an algorithm. An algorithm is going to take your outline in, very, very high order English, and what it's going to do is distill that down into a very complete set of keywords and instructions in pseudocode that you can take and develop into any other program language. From there, before we've done any coding in its development language, you are going to test the algorithm for correctness. This would involve going through and what is called the desk check. Now, we are going to highlight the desk check a little bit later on, not here in chapters 1 and 2 and 3, but later on when we get a little bit larger an application that really requires more carefully watched logic. Here in the beginning, as we're getting used to things, it will be relatively simple for you to go through and error correct the logic really simply, just keeping everything in your head. Later on down the line, that's when you really do benefit from desk checking the correctness of your algorithm. From here, page 3, step 5, is to code the algorithm into a specific programming language. We have gotten 5 out of 7 steps out of the way before it is that we have actually coded anything into the final deployment language here. What we do before this happens really does set up an environment where you are wasting less time figuring out as you're coding what the logic is. You are simply taking that logic and translating it into code. The second benefit to only coding here at step number 5 is to consider what happens when you're outsourcing all or some of the development process. Now, I know that outsourcing has a terrible social connotation now, because the first reaction you have been socialized to have as far as outsourcing goes says we are taking a job that my company could be doing and we're giving it to another company. We are essentially removing from my person, we are removing from my team in the company the ability to be able to code for that. And that's simply not always the case. A lot of good outsourcing is done here from one organization to another. A lot of good outsourcing here is done from one aspect of an organization to another. So just because you're involved in one phase even of the coding process does not mean that you are going to be involved in all phases of the coding process. You might be involved as a data engineer and getting together how it is going to work from one database to another. You might be a user experience engineer where you are actually putting together the touch point, how it is that a user is going to be entering or interacting with data. You might not necessarily be the same developer for both of those different versions or the different aspects of the project. So here, if you already have the logic in pseudocode, if you already know by and large, you already know what the individual steps, the concrete steps are going to be to actually complete your project. You can break it up into smaller pieces and have different development teams working simultaneously on putting together this project for you. Finally, step number 6, you'll run it on a computer. This seems like an afterthought at this point, but this is where you get to see over hundreds or hundreds of thousands of simulated interactions. If there's any logic in your data that comes about by, pieces of data that are outliers, outside of the usual expected or even unexpected but possible data entries. Towards the end of the semester, we might get a chance to talk about how some of this quality assurance engineering goes, where you would actually run the programs that you're working through an intermediary program that goes through and tests with good data, with bad data, with expected data, with repeated data, etc. And it does it hundreds of thousands of times in a relatively short period of time, so that you can see if there's any strange, bizarre logic that's going to have an impact on how your code is actually functioning. And finally is document and maintain the program. This seems, again, like an afterthought. You absolutely positively need to provide the end users or any stakeholders involved with some good, clear, measured, step-by-step orientation to how to use the project or the product. Over the long time, you're going to have to maintain, which means to change, to grow, to shrink, to make better your application. If you think about it, a good, well-designed application, program, operating system, what have you, lasts for a long time. Windows XP was released in 2001. By the time the end of 2017 came around, it was still the number 3 operating system used worldwide. Microsoft did not plan for Windows XP from 2001 to 2017 to be in constant development, but it was a piece of software that was so successful, it turned out it was in development for that long. So the better your product is made, oftentimes the longer it lasts, and the more time and energy you'll actually spend in maintenance and updates than you spent in time and energy to get the first product up and running in the first place. So that is 1.1 steps in program development.